Jai Hind to all. Myself Pancham Singh. I am going to deliver one of the important topic in software engineering, that is software evaluation and maintenance. So in this lecture, I will discuss about the various evolution of the software, and the second thing is how you are going to maintain the software. So these two terms are very important in software engineering: evaluation and maintenance. So evaluation in generation of different softwares as per the requirement of the user, as per the requirement of the client, and maintenance is another important topic in software engineering, where how you are going to maintain the software. So today agenda, I will discuss about the some key important points, that is outlines of the topic. The first topic is evaluation versus maintenance. How evaluation and maintenance both play a key role in software engineering, and what are the phases of evaluation, and how maintenance is going to affect, or you can say influenced by the evaluation. That is the important. So first point means 1.1.1 is software evaluation and software maintenance. So there are two key terms, software evaluation and software maintenance, which our agenda will discuss in detail. So first and second point is software evaluation models and processes. So what are the evaluation process and what are the software evaluation models? So basically a process, the way you are going to design a software. And what is the evaluation? So we are going to evaluate the software as per the requirement, time to time, and we are going to design a new model as per the client requirement, as per the user requirement. So evaluation can be changed as per the requirement, but we are going to use the same process in which we are going to design a new evaluation. Second, third important point is re-engineering. So re-engineering means we are going to rearrange the things. That is re-engineering. Again and again we are going to evaluate. If you have evaluated one time and you are going to evaluate again, then you will follow the re-engineering concept. Next point is legacy system. So legacy means what is the basic evaluation strategy, basic evaluation model on which we are going to work on. That is legacy. Impact analysis. What are the impact of the hardware? What are the impact of the nature? What are the impact of the environment to developing a software? So these are the major challenges in software engineering. Refactoring. Is it important to refactor the software? And why refactoring is important in software engineering? That is the another key part which play a major role in software engineering. Next is program comprehensive. So how program is comprehensive in such a way that we are going to work on and we are getting the results. So these are the software reuse, means how you are going to reuse the software. That is reusability, because software is work on a reusability concept. So the code, the section which you want to use again, you can use in software engineering in development field. So these are the main topic, or you can say these are the outlines of the software engineering topics in today's agenda. Now the first point is 1.1 evaluation versus maintenance. So the term evaluation and maintenance is concerned about the design and updation of the software. Second point is, however, there is a semantic difference. Level J. Arthur distinguished the two terms follow. So one of the software engineer who has distinguished between maintenance and evolution there are two important difference points is given below. Software maintenance means to preserve from failure or decline. The things which are not giving the good result, the things which are not giving the accurate result, that need the maintenance. What is the evolution? Software evolution means a continuous change from lesser simple or worse state to a higher or better state. So evolution means we are going to upgrade the software. We are going to enhance the software. We are going to change the software. Why we are going to change the software? Because we are going to update for better result. We are going to update for higher accuracy, higher result, or you can say more user friendly. So these are the terms which are going to use in the evaluation. Now Keith H. Bennett and Liu use the terms software maintenance and reliability in other way. Maintenance for all post-delivery support and evolution to those driven by changes in the requirement. So what changes we are doing? You can do the changes, but somehow the changes will create the problem in the software and we are getting not good result, not correct result. So we need the maintenance. So maintenance is required either there is some errors or bugs, or we are going to update the software and maybe it will not compatible, not feasible, and we are not getting the accurate result. So we need the maintenance. Now maintenance is considered to be set of planned activities, whereas evolution concern whatever happens to a system over time. So maintenance means the things which you are facing, we are getting the error and we are removing that type of errors, bugs. But what about the evolution? The term evolution concern whatever happened to a system over time. What happened in the previously and what is your plan now to enhance the model, to upgrade the model for betterment. Mehdi Jawar's view on software evolution. So one more evolution point of Mehdi Jawars has given, concluded that over time what involved is not the software. What involved is not the software, but our knowledge about a particular type of software. So our knowledge is particular type of software because our knowledge is day by day is going to update. Our knowledge is going to day by day need updation. Then you will use the concept of maintenance. So software maintenance or software evolution, both are the key terms where evolution changing the new way of the software, and maintenance whatever you are getting the errors, bugs, problems in the software, then you are going to update or you are going to rectify, correct that errors from the software. Software evolution are some important points are given by the Mark Halpern used the term evolution to define the dynamic growth of software. So in 1965, Mark Halpern used the term evolution to define the dynamic growth of software. So why software is dynamic? In 1970, the term evolution is referred relation to application system took gradually in the so in 1970, the evolution is going to upgrade. Similarly, by the IBM, Lehman and his collaborators from IBM are generally credited with the pioneer in the research field of the software evolution. So these are the some key important points, and through which we are going to evaluate the software, to upgrade the software, to know the feature of the software. So these are the some important key part या key points which will influence the designing and developing or evolution of the software by the different person has given their opinion. On the basis of that, we are going to upgrade the software, maintain the software, and enhance the software. So software evolution, there are some important laws that is given by the Lehman. So Lehman has given the first law, that is continuing change. So as you know that nature is going to change continuously. So why software is not? A software is going to change means what is required to change in the software. That is the big question. A system will become progressively less satisfying to its user over time unless it is continually adapted to meet new needs. Why we need changing? Why we need change? Because what you are expecting, you are not getting. You are not getting, you are not satisfied. Then the need of the software, the change of the software is required. Now second point is increasing complexity. A system will become progressively more complex unless work is done to explicitly reduce the complexity. Unless software is not launched, unless you are not performing their work, you cannot measure the complexity of the software. So complexity is another important parameter in software evolution. Self-regulation. The process of software evolution is self-regulating with respect to the distribution of the product and process, affect artifacts that are produced. So what are the software products या process you have applied for the self-regulation? That is important. The process of software evolution is self-regulating with respect to the distribution of the product and processes. What processes you have applied, on which product you have applied, that is self-regulation. Next point is conservation of organization stability. The average effective global activities rate on an evolving system does not change over time. That is the average amount of work that goes into each release is about the same. So conservation of organizational stability. What is conservation? What is stable? And what you are going to update? That is important. So these are the four important law of Lehman start from the continuing changes, increasing complexity, self-regulation, and conservation of organization stability. Now next law, that is fifth law, is conservation of familiarity. The amount of new content in each successive release of a system tends to stay constant or decrease over time. So somehow some keywords you have taken, but time to time it is going to not used, yeah, decreasing over the time. So we need the conservation of familiarity. We are going to use the new content to leave out the old content on which we are going to work on. Next law, that is the sixth law, that is the continuing growth. The amount of functionality in a system will increase over time in order to please its users. So what amount type of functionality we are using for increasing over time for continuous growth of the software. So continuously growth means we are going to work on the functionality of the software. We are going to work on the design process. We are going to work on the implementation process, and we are going to work on the technology process. So some important parameters, maybe it will help to grow in software development. declining quality. A system will be precise as losing quality over time unless its design is carefully maintained, adapted to new operational constraints. So decline quality, so system maybe we are going to losing quality over time, to somehow we are using the software but we are not getting the quality in terms of the result, in terms of the look and feel, in terms of the user friendly. So these are the some important parameters through which on passing the time it will not giving the good result, or we are not giving the good impact. Now what about the feedback system? So we are taking the feedback from the user, from the social media and from many platforms. So on the basis of that we are going to improve the quality of the software, interaction of the software, GUI of the software. So these are the parameters basically play a key role for designing of the software, or you can say evaluation of the software. Software evaluation is also work lies is in Singh का 1988 फिर ज़्यादा point out the difference between the evaluation of the Unix OS and system studied by the layman. So earlier we have Force system has studied some operating systems and their behavior, how it is different than other operating system. So that is the important, because there are many n number of operating systems are there, but their features, their functionality, their interaction, their GUI are different. Maybe some operating system is used as a personal level, some operating system is used as a network based operating system, some operating system is used as a admin based. So maybe they have designed from different perspective and they are working. So these are the basic importance of designing a software by FOSS system. Software maintenance, there will be always a defect in the delivered software. Application becomes software, defect removal and quality control are not perfect. So quality control means we are going to maintain the quality of the software. So how you will maintain the quality? Timely evaluation of the software, timely identify of the bugs, timely maintain of the software. So there are different phases in which we are going to evaluate, rectify and maintain the software. Therefore, software maintenance is needed to repair these defects in the release software. So maintenance means we are going to maintain, we are going to find out the errors, we are going to find out the accurate result. So these are the maintenance terms. So maintenance we are going to maintain in every areas of the software, in the form of the result, in the form of the look and feel, in the form of the GUI, in the form of the user friendly. So these are the different parameters which generally helps to use the software maintenance. Software maintenance, basically we are going to maintain the software, but there is some standard software standards are there given, like ISO and IES. They are follow the some standard guidelines on which we are going to maintain the software, because every company have the standard to maintaining, to giving the service of the product. So they have the written information, on the basis of that they are working. So software maintenance is very important for designing, deployment and implementation. So maintenance is the last phase where we are going to maintain the software, what are the errors are there and how you are going to find out the errors and solve the problems as per the requirements. These are the some points that can be discussed by the another one, and basically This category is subdivided into three types. Software maintenance basically divided into three types. The first one is the enhancement that change existing requirements. So what are the existing requirements and how you are going to change as per the requirement. Enhancements that add new system requirements. Enhancement that changes the implementation but not the requirement. So what is the enhancement? So enhancing the previous one and updating by new ones. Enhancing the older one, updating by the new design, new process and for betterment. So these are the maintenance part. Maintenance is really very important for software engineering, and every software maintained by the software maintenance engineer time to time. And why they are maintaining? Because they are maintaining to calculating the correct result, and as per the requirement. If you are not getting the result, then maintenance is required. Maybe some errors or bugs may be occur in the system, and by using the maintenance we can remove all types of errors, all types of bugs from the systems and software, and we will get the results. Software maintenance is another important point is here. The major difference between the components based software systems and customer build software system, that is COTS. So skills of the system maintenance team. So the team which is going to maintain the software must be trained. If the team is not trained, they will not maintaining the software properly. They are not removing the errors, bugs, yeah, find out the results of the software. Infrastructure and organization. So where your software is working, where you are doing the work, that is totally based upon the infrastructure and organization. COTS maintenance cost. What is the cost of the software? Means what is the customer build system, software system, what is the cost? So cost is the big challenge in software development. So if you are going to develop a software, so cost calculation, cost measurement, cost prediction is the key point in software engineering. Whatever you are going to develop a model, design a software, so cost is a major parameter. So how you are going to calculate the cost of the software, that is the important. Modelization, time to time you are going to update the software. We are using the latest technology models for designing a software. Split maintenance function, we can divide the software into the different parts so that we can easily maintain the software. More complex planning. So what are the planning in the software? How you are going to plan this particular software? So that is the important part of the maintenance. Software user models and processes. Maybe there are some important models that is the defined below. The first model is staged model of maintenance and evolution, iterative model, and last one is change mini cycle model. So these are the three important models in software evolution models. So software evolution model life cycle is divided into three important models. These are the models. So software maintenance standard, they are following the some guidelines, some standard through which they are going to give the service. They are giving the results. So these are the guidelines, yeah, standard through which any company, if they are registered, they must follow the ISO guidelines for giving the service, giving the maintenance. Software configuration management. So if you are going to configure a software, so why it is important? So software configuration management is the discipline of managing and controlling change in the evolution of the software. So what are you going to change in the software? and how you are going to control that software, that is the important for software configuration management. It ensures that the release software is not contaminated by uncontrolled or unapproved changes. So what changes you have did in the software, they are not affecting to the other modules, which will create the problem. So the changes is required, but it cannot be harmful or affected by the other model of the software, and we are getting the result. So these are the some important key parts in the software configuration management. So configuration means we are going to change and we are going to manage. So these three terms will run simultaneously whenever you are going to maintain the software. An SCM system has 4 different elements. That is, first is identification of software configuration, control of the software configuration, auditing software configuration, accounting software configuration. So these are the some important points in software configuration. What is the re-engineering? Re-engineering is done to transform an existing lesser or simpler system into new better system. That is re-engineering. Re-engineering means we are working on the base model and we are enhancing that model for the betterment. That is re-engineering. So these are the re-engineering, and the term re-engineering is equals to reverse engineering plus forward engineering. So we are going to reverse the process and move for the forward process for betterment. That is reverse engineering. So reverse means we are going to check the older one and upgrading that older one to getting the new result. That is the re-engineering. So this is the re-engineering, not reverse engineering. Re-engineering means reverse engineering plus forward engineering. Legacy. A legacy system is an old system which is valuable for the company, which often developed as and own it. So what is the legacy? Who has given to you legacy? Sometimes you are asking, what is your legacy? So a legacy system is an old system which is valuable for the company, which often developed and own it. इसको आपने develop किया and इसको own किया. So these are the points of the legacy. जिसमें freeze, outsource, carry on maintenance, discard, wrap, mitigate. So these are the legacy points. And what are the impact analysis? So impact analysis is the task of estimating the part of the software that can be affected if a proposed change request is made. So maybe we are going to change in the software, maybe it will affect the whole software, it will affect the whole result of the software. That can be impact of the software. So impact means something we are going to change, it will influence the whole system of the software. So these are the impact, where that is, there are some important impact like ripple impact, effect, change propagation, refactoring. So these are the terms basically used in the software, is used in the design of the software, for reconstructing of the software. So refactoring and the impact analysis, re-engineering and reverse engineering. So these are the terms very important for software engineering whenever you're going to design a software, design a new model. So that can be help for designing a software. So program comprehension. So these are the some comprehension of the program. So software reuse means if you're going to reuse the software, it means that we are going to use the software again and again. Reuse means we are going to use the software again and again. Software reuse was introduced by the Duff McLeod in the 1968 SEMI paper. So they have use the concept of software reuse. So these are the reuse concept, and thank you very much.